Hey everybody, I was going to go over an example of a problem in lesson 7.5, estimating a mean. Before I do that, I'm going to actually go over some important ideas from the text. So first thing, conditions. Okay, and these conditions have not changed from before. First thing they want to ask you, is it random? Basically what you're doing is you're looking for in the text or in the question, is it a random sample or do they say SRS? Okay, so if they say random sample, you're good to go for random. The next part is normal. Is it normal? So if the problem says the population distribution is normal, that works. Or if they don't say anything that the population distribution is normal, then you want to use or see if n is greater than or equal to 30. Remember, n is just your sample size. So is n greater than or equal to 30? And that's the central limit theorem. Okay, so first thing, conditions. So check the conditions. The second thing here is something new for us. We've got a t-score. So instead of using table A for a z-score, we're going to use table B for a t-score. And the real difference between z and t, z is for proportions and t is for means. So they'll say in the problem, the mean is this, or basically, remember, a proportion is like a percentage. So if they don't have any percentages or a fraction or a ratio, then you're probably just going to be using a mean. So that's t-score. And with this, you need this thing called degrees of freedom, so df. And what that is just n minus 1, n being your sample size. And again, we're going to use table B for this. And I'll show you how to use it. And then the third important idea from the text is finding that confidence interval. So your point estimate plus or minus your margin error. Okay, your point estimate is just your mean, x bar, and then plus or minus the t-score times the standard deviation over the square root of your sample size. And those are the three key ideas from the text. So now I'm going to do an example. So here, a study of commuting times reports the travel times to work of a random sample of 40 employed adults in New York State. The mean is 31.25 minutes, and the standard deviation is 21.88 minutes. Verify that the conditions are met for constructing a confidence interval for the mean. So this is number one. So we want to check the conditions. So basically, are we random, and is it normal? So let's talk about random. Well, in the problem, I see here a random sample. So they say, so I'm just going to quote it, random sample of 40. So that works. Normal. So in the problem, it doesn't say anything about the population distribution being normal. So I'm going to use that the large sample size. Large sample size. This is just your is n greater than or equal to 30. Okay, that central limit theorem. Well, our n is 40, which is greater than or equal to 30. So the central limit theorem tells us that it's normal. So we're good to go there. So that's all you got to do for that first part. The second part here, construct a 95% confidence interval for the mean. Okay, now this is where I'm going to need that formula down here, the point estimate plus the margin of error. So I'm just going to go ahead and write that out. Point estimate plus or minus margin error. Okay, so that's that X bar, or the mean, plus or minus your T times the standard deviation divided by the square root of n. All right, so our mean in our problem, they tell us, is 31.25 minutes. So I'm going to plug that in. 31.25. Okay. Our T, to get our T, okay, to get this T, we need to know our degrees of freedom. And to get that degrees of freedom, right, that was just n minus 1, or 40 minus 1, which is 39. So I'm going to to get the T, I need to use table B. This is table B right here. I think yours on Google Classroom looks a little bit different, but honestly, it's the same numbers, it's the same thing. So to read table B, if you notice here off to the left, we've got our degrees of freedom, and then on the bottom we have our confidence interval. So we need those two things in order to find what T we're going to use. So I'm going back to my problem here. So my degrees of freedom are 39 and my confidence interval is 95, or 95 confidence level. So back to my table here. So confidence level is 95 down here. And we're just going to kind of look up that row or that column. And then I need 39. Well, I notice over here off to the left that I have 30 and I have 40. I don't have a 39. If that's the case, then you want to go with the lower number. Go with the 30. Don't go with the 40. Okay. Now all I'm doing is just going to go across here until I hit the 95 and I see 2.042. So that is the T that I want to use for this problem. So 2.042 times my standard deviation that they give me, I'm going to go back to my standard deviation here, is 21.88. So times 21.88 divided by the square root of n, right? N is 40. Okay. Now I'm going to plug that right side in. So I've got 31.25 plus or minus. When I plug that into the calculator, I get 7.064. All right. Now our confidence interval, remember it has a lower bound and an upper bound. So I'm going to take this 31.25 and subtract first 7.064, and I get 24.186. Okay. And then next we'll add to get the upper, and it'll be 38.314. Okay, so there is my confidence interval. Last question, of course, they're going to ask you to analyze something. So here, is it plausible that the average commute time is actually 20 minutes? Okay. Well, if we think about what does this confidence interval really mean? It means that we're 95% confident, I get the 95 from the 95% confidence interval, that the true average, we're 95% confident that the true average falls between 24.186 and 38.314, okay? Now, this question, is it plausible that the average commute time is actually 20 minutes? Well, does 20 minutes fall within that interval of 24.186 and 38.314? No. 20 is not contained in the interval. And that's all you would have to say, okay? If you have any other questions, please let me know. Hopefully this will help you get started on on the assignment. All right, have a great day.